So I see you back
we lost
again.
You for the last 1 minute.
Okay. All I was saying was about the future of QCX and the importance of analog design around SDR. And the last slide, I was giving some links to QCX Plus and QCX Mini on the QRP Labs website, and the prices I had put on there as well. So that was the end of the presentation, Farhan. So thanks very much, everybody, for listening, and I hope you found it interesting. There's a lot more information on the QRP Labs website if you're interested in aspects of technical design, or if you want to try one. We have lots of stock. So any questions? I'll be happy to answer any questions if anybody has any questions. I don't know if you can still hear me, but I have no audio from you.
Hello,
or
Hans,
video.
we lost you.
Yeah, hello.
But I'm just trying. Yeah. Can you hear me now? Hello?
Yes, I can hear you, yeah.
Hans, can you hear me now?
I can hear you, yes, I hear you.
Hello?
I hear you, yes. I'm hearing you. I don't know if you can hear me. It seems not. I hear you.
Hello?
Hello, can you hear me?
Hello? Wi-Fi is not coming.
I can hear you, but I don't think you can hear me. But nothing changed on my side. I hear you.
Announcement while we reconnect the announcement, the KNN Homebrew contest will be held shortly. So please give your names. Those of you who have not given the names, give the names, and it will be held here after the next session. So please, and those of you who have got the feedback forms, give us the feedback forms at the reception, at the registration counter. So drop in at the box that is provided at the registration counter. Be brutally honest, because we need your suggestions so that we can improve. We won't feel bad, but we will try to improve. So if there is anything lacking in us, please let us know so that we can improve upon our performance. Thank you so much.
Hans, can you hear me now, Hans? Hello? Hello? Hello?
అమ్మా ఎక్కడ పోయింది వాటర్ అని తాగేసి ఏంటి కాల్ చేయి వాటర్ ఇక్కడ ఉన్నప్పుడు ఉండాలి కదా तुम्हारे गाँव में पानी गिला है बड़े मीटिंग में भर्ती लग रही है లేదంటే నువ్వు రాస్తావా ఆమె తెలుసు కదా ఆమె రాని വിളിക്കാതെ ഇരിക്കുന്നതാണ് That be
Hi, Hans, can you hear me now? Hello, Hans, can you hear me now?
Yes, I can hear you.
All right, sorry, we had an outage, so I had to switch back to my mobile hotspot. The last slide, you'll have to restart it over again, okay? The last one. Okay.
I have the slide still on there.
Yeah. You have it. So I'm just plugging you into the PA system. All right. So all right, here you go. Let's start again.
Okay. I think you heard the last slide, which just has some links to the QCX Plus and QCX Mini. And so I was asking if anybody had any questions about it, or comments, or anything, anybody in the audience.
Okay, so I'll take some questions and I'll pass them through to you. Anybody with questions for Hans here? I think there are quite a few people who are trying to ask some questions. Okay, Hans, what I'm going to do is I'm going to put the questions on the chat box, because otherwise there's a public address system, feedback loop, so they'll not be able to hear you answer back again. All right, hang on. I'll just do that.
Green.
And so you want me to answer the questions on the audio, but take the questions on the chat box. The question from Thomas VU2TZ. I'm going to answer on the audio. I assume that's correct. I'm not planning to update QCX software into the SDR. Thomas, I think what you're referring to is the USDX project, which is a project that grew out of QCX and implemented an SDR on the Atmega 328 chip. And the SDR that's implemented by that approach, to me, it was the code was done by Guido, PE1NNZ, and that's a fantastic feat of programming, in my opinion. Fascinating that he managed to do all of that in such a processor. However, there are very, very severe limitations on the performance that are imposed by doing that. And basically the ADC in the Atmega 328 is a 10-bit ADC, and how it works with ADCs is that you get 60 dB of dynamic range per bit. So the maximum dynamic range that could be attained on a USDX is about 60 dB of dynamic range, and in practice it probably is less than that. Furthermore, in order to get an output signal of SSB from a Class E amplifier, they have to use this technique called Class E envelope restoration, which is also quite limiting in performance. So the USDX project is a very fascinating project and a nice low-cost radio, but the performance is very much less than the QCX. QCX performance is like when you use your Kenwood ICOM or your Elecroft or anything like that. Interesting story, by the way. First, when I had a prototype in 2017, and I was going to Germany for the Friedrichshafen Hamfest in Germany in June 2017, and I had with me the prototype of the QCX, and I was in the shack of Hannes DL9SCO, who is one of the founders of Palm Radio Keys. And he has a whole lineup of all the aircraft stuff that you can imagine, all these black boxes along his shelf. And we tuned around and we managed to find one signal on 20 meters, which was what my QCX was for. One very weak signal we could find on the QCX. And we swapped his antenna over to his K3S, his aircraft K3S, and it sounded exactly the same. And so it was a very impressive moment for me that the performance was really very impressive and kind of equivalent to these top radios. So I'm not going to, I found the USDX project to be very fascinating and interesting, but it's not a direction that I want to head in myself, because I have tried to make a name with the QRP Labs products for very high performance and low cost, and the USDX project really doesn't have that level of performance. The multiband version of QCX, I'm not actually planning a multiband version of QCX directly. I'm planning to, I have been planning for some years to produce an all-mode, all-HF multiband radio called QSX, which is based on SDR technology. And so that's something which I've had in development for some years, and it's taking way longer than I had hoped. Final question, how much time does the documentation take? Actually, you'd be surprised. A lot less time than you would think. I'm very quick with typing, and I don't think I spent more than 3 or 4 days writing the entire documentation for QCX. Even though it's 150 pages, I get really into it and very focused on it, and type very quickly, and usually what flow of consciousness comes out of my mouth in the technical descriptions is what ends up the final thing. So any other questions? Firehand's typing something. How many QCXs were sold to India? It's an interesting question that I do not know off the top of my head, but I can open my spreadsheet and I can easily find out that. If I could find my spreadsheet, my PC. Somebody's got the QCX Mini there, very nice. So in that case, we know at least one was sold to India. Okay, I'm just opening my spreadsheet, and I can do a quick filter on country. We sell about 45% of QRP Lab stuff goes to America. And about 15% goes to Germany, 15% goes to England, and the rest goes to everybody else. Every month we ship out about 600 orders, and not just QCX, but all the other QRP Labs kits as well. We have a new digital mode kit, QDX, in the last year, which has also been very popular. Every year we're shipping out. Every month we're shipping out about 600 kits, and of those only one or two go to Turkey, local customers in Turkey. So I'm just looking up. We apparently have sold 3 QCX Pluses to Turkey, to India, only 3, and 4 QCX Minis. So a total of 7 QCXs in the last 3.5 years to India means about 2 per year. So it's not very many. It would be nice. It would be certainly nice for Indian amateurs to. Yeah. So only 7 so far.
So you'll have to just take photographs. Huh? Right, okay.
I can't hear you, Farhan. I can see you talking.
Behind schedule today because of the rains here. I don't know if you've checked the news, but there's a huge cyclonic storm over this area.
I can't hear you.
Oh, you can't? I think you'll be able to hear me now.
Yes, I can hear you now.
So we started a little late, so we're running a little late for lunch now. But thanks so much for being here with us. And a lot of people actually homebrewed the QCX, and they are here in the audience. So they are very keen on listening to you. And actually, this is being relayed to a couple of other halls here as well. And we've streamed this on Q100, so a couple of people from BATV gang have been watching this. It's streamed on YouTube as well, but not many people on the YouTube looking at it right now. We'll have this uploaded if you have the permission in the next 24 hours on the
Sure, yeah.
on the YouTube. All right. Thanks so much, Hans, and looking forward to see you quickly again.
Thank you. My pleasure. Thank you
Yeah.
very much.
Bye.
Take care and enjoy the rest of your day.
Yeah.
I wish I was there with you.
Yeah, probably next year you should make it here. This is a lovely time to be
Maybe.
here. Yeah, yeah, with your family
Thanks a lot.
probably. Bye bye.
Take care. Bye bye now.
Yeah, so I'll just put this.
Yeah. Yeah. Again, an announcement that those of you who want to take part in the KNN Homebrew contest, please give your names because we will have it immediately after the next session. So, please give your name at the counter. And we also want you to give us your feedbacks, honest feedback on the event. So if you can fill in the feedback form and drop it at in the box provided at the registration counter, we would be very grateful. Thank you. Also, before we have this thing, Farhan. Okay, we have another small this thing. We have two enthusiastic SWLs, kids, who are very eager to take part in, they have been already a part of the amateur radio group, and they really are very good in homebrew, and they are also learning on Morse code, and we really want to acknowledge them. They are kids. So I request Arun, could you please come on stage and give this. Jai, Charan and Ashwin, both of you come here. Yes. So they're very interested in homebrew.
I know, that's impressive. I've gone through some of the stuff that they've done. Congratulations.
Thanks.
This is Jai, Charan. Let's give them a big round of applause, please. Thank you so much. Next year you should present something here. Okay? Good. Thank you so much. Okay, we have a next session. We have on the use of digital modes in amateur radio by View 3 TBR, Balasubramaniam. So I hand it over to him. Please go ahead, sir.
Somebody already from Bangalore. Can I have one?
QCX, sir.
Like USB.
QSP, I'll give you.
One cup. I told him that I'll try.
I'll give you.
What type of
We will always accommodate for you. But there are some people who will unnecessarily take a big...
Libre Express? It will not open. I need a possibility. No, I'll bring my bag. You don't have any windows with the PPTs.
I don't know, sir. Actually, this is a USB is connected with this lappy, and it will be project on screen.
Sir, no, hang on, let's do this. Can I take that away? Yeah, yeah. Huh? Yeah, yeah. No, no, I'll take this away. You use this, okay? Yeah. Yeah, yeah.
And behind them is the Wi-Fi.
Behind every successful man stands a surprised woman. You don't believe.
Then you go adapter. ये Mac.
Yeah, yeah.
Everyone gone for your
அவங்களோட லிப்ரேல வச்சிருக்காங்க பிபிடி இருக்கான்னு கேட்டா ஆமான்னு சொல்லிட்டு பார்த்தா லிப்ரேல இன்னும் இருக்காங்க
Not coming.
Yeah, एक मिनट सेट करते हैं
एलजी में बोर्ड है ना
No, it will come direct automatically. 1 minute, program will start.
अच्छा वो नहीं
यूएसबी में नहीं आ रहा।
तो क्या पता नहीं
वो
और
डायरेक्ट
ये नहीं आ रहा सच में।
वो तो मान गया लेकिन अभी क्या पता अभी
कनेक्ट करना शायद।
एक मिनट
डिस्प्ले नहीं आ रहा।
ये है तो सही
ये कलर क्या लेना, कलर एलसीडी डिस्प्ले क्या लेना है? व्हाट टाइप ऑफ डिस्प्ले इट इज? पाल मेसिका कौन सा लेना है?
पावर पॉइंट है क्या
हाँ पावर पॉइंट है, डिस्प्ले तो लेना है ना। वो
तो
ऑटोमेटिक
ऑलरेडी आपके ले रखा होगा ना उसमें, आप एक बार उसको करो तो आ जाएगा उसमें।
प्रोजेक्ट नहीं बता रहे।
ऑब्जेक्टिंग तो नहीं बचा रहा तो
एक मिनट देखते हैं अभी
डिस्प्ले में प्रेस
इसमें
Announcement. All the contest people, homebrew contest, those who have given the names, please come to the front. All the participants who have given your names for the KNN homebrew contest, please come to the front. No, that. Come along with the equipment that you have to present. Come along with the equipment that you have to present. Please come. Homebrew contest. Yeah. Please come with what you have to present. Yes.
दूसरा लैपटॉप लाओ।
हाँ दूसरा लैपटॉप लाके उसको कनेक्ट करो। अभी ये नहीं आ रहा ना।
Okay? So just be here only in one place.
Hello. Anybody has a laptop, PC laptop?
If you find him in
If you can help.
Otherwise I can't.
PC laptop.
Laptop. Just find out laptop. He needs a different laptop. You have a? Here there is a laptop.
सर आर के सारे
Here. Aditya, there's a laptop here.
इसमें अगर डायरेक्ट HDMI निकालना
Adobe. Just need to boot up. That's okay, but I pulled it out from the top. So sometimes they will look for
No problem. इससे चलेगा। इधर connect।
One second. I'll boot it up.
इसको connect करो, देखते हैं। You want the mouse? Function.
डिस्प्ले सेटिंग्स
दूसरा डॉक्टर
वो भी शो नहीं कर रहा। हाँ वो भी शो
MacBook का है। ये एकदम आ जाता है।
Railway station
മാഷിന് ചെറിയ പാക്കറ്റ് വാങ്ങിച്ച് വീട്ടിൽ വെക്കണം.
Then I am connecting it.
ഞാൻ വിളിച്ചപ്പോൾ യശ്വന്തപൂരിൽ നിന്നാണ് പറഞ്ഞത് വിളിച്ചത്.
USB connected.
Put it here. Then until you set up now, we will go ahead with the contest. Just after the market luggage
I'll join last.
Check. The homebrew contest, all the homebrew contest, please come on stage. All those who have given the names for homebrew contest, come on stage with your display, whatever you have done.
इधर से करो.
हाँ लेके आना all.
अगर ये ऑप्शन आता है वो मुझे पता चलेगा.
Sir, I'm on stage.
My office laptop was settled by the connect.
VU2 X-ray Zulu, Shashi. Are you around?
One minute. One minute.
One by one they should present.
One by one they should
Okay.
let them come down and one by one go there and present them.
जाऊँ पर कि नहीं?
No, one by one only. No need all at there.
Why don't you show it?
Sir, I'm in this thing. I'm having an event. I'm on the stage.
Coming?
It's not a PDF, it's PowerPoint.
Yeah. These are already 9 contestants.
Oh, okay.
So you have to just this thing. Okay. Where are the rest? It's with them. 9 people have given us the names. Who? Ah, it's there. Ah, he's got, come quickly. Okay. No, we just want to take this thing and then we'll go down and one by one come and present the, so that we can take a collective. Yeah, TBR, please.
Yeah.
You are also presenting, right?
Yes.
Yeah. Just one snapshot. One, this thing. All are there, 3. One more missing. Yeah, the list, if you just read out the names. 9 people are there.
VU3CER.
Yeah, VU3CER, VU2PTR, then Jai Charan, the kid, where are you? Quickly come. Then, yeah, VU2UPX, VU3TBR, then VU2LWE, Pradeep. Where is VU2LWE? Is he here or VU2LWE, Pradeep? Okay, VU2KD, okay. Then VU3OSA, right? Then Aditya, VU2TUW, okay. So now we can come down. VU2LWE, okay, he is missing. Now come down and we'll start. You give the first presentation. Come. You can keep it here. Immediately, one by one. Here. You have the mic.
One second, give me time. 1 second.
No, then somebody else will. I'll ask somebody else. Oh, okay. Yeah, please. You can see. Sure. You don't mind. वो लोग दोनों हाथ फ्री रहना तो आप उसको माइक पकड़ के देना
बोलेंगे मेरे को नहीं जरूरत नहीं अब हो गया Can I start? Hello everyone, I am Aditya, VU2TUW. So this is a small scale rotator that I built, and it consists of two motors, one of 10 RPM and the other of 30 RPM, and it has been reduced by a worm gear, and it can point direct with an accuracy of ±5 degrees. And it can take up, this is a single, this is a Yagi, please ignore the condition of the antenna. But yes, I have a demonstration in which we can mount a dish on it as well. So a dish becomes a D, and it can take the load of a small scale 2.5 kg dish as well, if you put a proper counterweight along with it. So this works on 12 volts, maximum 3 amps we can take for this. So it has two sensors, one MPU sensor and one compass sensor. This is just for programming this cable, but we are removing this and we are adding a Bluetooth module into this. I am adding a Bluetooth module into this so that we can directly through our laptop without any cables, we can directly put up code also. We can give direct manual commands also. The control board has manual switches as well. Also, you can give manual commands in the serial monitor also. There is no problem. We can directly manually control it as well, along with G-Predict also. If you want no connections, you can just adjust the buttons to where you want it to point. It will point till it is on. If I don't think I will be able to turn this on, but yeah, I can present a demo over there. But if I program it to point in a certain direction, and if I tilt it also, it will keep on pointing in that direction with the accuracy of ±5 degrees at the moment. And we can improve the accuracy as I can develop the software on it as well. Okay, thank you.
PTRs. I'll connect it here.
Yellow sir.
But you didn't show the working?
Sir, working I can show you.
Where?
Can I go out? Huh?
No. Who's next?
Yeah. No, he is.
No, what I...
Yeah, can I go ahead?
Some of the other guys will ask.
Okay, please go ahead.
Hello. Good morning and good afternoon, everybody. It's already noon now. This is I'm talking about a digital mode of communication. In the digital mode of communication, there are a couple of protocols like D-Star, DMR, NXTN, etc. So, for each company has made their own protocol. It cannot talk interchangeably. Like you have to talk to DMR, you need to have a radio of Motorola, Anytone, Radio DT or anything which supports the DMR. But at the same time, you want to use the same radio for D-Star, you cannot do that. You have to buy a radio with a ICOM and other people making a D-Star radio. For Yasu C4FM, you need a Yasu radio. So this has been a big challenge. For anybody coming into digital mode of communication, they have to buy 20,000 each handy. So about, let us say about 80,000 rupees, plus a hotspot another 1 lakh rupee you have to spend. This has been a real challenge for all the new hams, especially the student section. They are studying, their father, mother is spending so much money on the education. They cannot give such a money for the investment of buying 4 radios, etc. Even if one radio is a big challenge. So I was thinking, mooting out for the last 2 years, how to go about this thing. Like Farhan did $100 UBTEX. I wanted to do something very similar to that. So for the fraternity of student and other community, I just wanted to do that. So I found a way. I thought there are 2 components involved in that. One is a radio, RF radio, which is you are talking with this hotspot, and also that radio cost. So we are talking about 60,000 rupees investment on that. So because there are board from MMDVM, which is very expensive. Nowadays the board costs even 6,000-7,000 rupees, Now the Zero Pi, Raspberry Pi, you need another component, which also is equally expensive. So nobody, first of all, even if you are willing to pay money, you cannot buy this one. So I mooted out an idea how to go about what it should not be done. So every company having their own chip to talk to the local, it is a function of a repeater. Hotspot is nothing but a function of a repeater. So I thought I should bring in the coding, transcoding into the hotspot instead of radio level. Then I bought identified one chip, SA818, which is a beautiful chip. And there is also, it has got a transcoder built in. There is also a SA828 with a DMR also built in, that transcoder. It's called a AMBI 3000R. So that both can be done. But what the earlier one 818 cost you about $10, and the DMR 828 cost you something like close to about $40. So again the cost issue. But these are all tackled by MD380 software solution, excepting for D-Star, DMR, Fusion, NXT, and all can talk without a hardware dongle. So with the 818 it can perform. So this set of what I have made is a fully working module. For 6 months I have been running, and I want to show one more thing. This is the my previous board, and now I have made it to look very small with this PCB board. So this is the type I would like to bring. We will put an antenna here so it can talk to the local radio. So this is going to be, it is also fully functional. RX, TX both are functional. It can support about 6 or 8 protocols. And the idea is to bring out, this will cost now presently 18 to 20,000 rupees because I'm paying excise duty, GST, custom duty, all this. So if the parts are also very difficult to do it. But over a period of time, I intend to improve.
You want me to hold okay. Huh? Yeah, after that. Yeah. You can, because it will take some time. Yeah.
Hi, my name is Dhiru, and my call sign is VU3 Charlie Echo Romeo. Today I am going to present the 5 transceiver, which I have named PDX++. I have worked on this design with WB2 CBA, Bob. You might know Bob from the ADX design, micro SDX design, which are very popular in India. And a lot of people have built those designs. So we have a small WhatsApp working group where I worked with Bob, Dr. Pedro, Alan, all from different countries, I think. I don't know actually their countries, but it was a diverse working group and fun. And the thing about this radio is that it's fully open source, including the KiCad files. You can go to my GitHub, you'll get the KiCad files. You can extend it. That's my purpose, to bring a 1600 rupees to 2000 rupees digital transceiver to you. It's fully open source, including the source code. And I also open source my references so you can learn where I learned from. Right? That's my purpose. There are various challenges with it. Currently, it suffers from broadcast interference. I live near a 100 kilowatt station. So as you can imagine, my working conditions are a bit tough sometimes on such receivers. So what I have done is now that the next version of this will be, I'll be basing it on SI4732, which has a quadrature based, like the Hans explained the quadrature mixer on his slides. It has that. It has a LNA in front. Then it has SSB, DSP, and everything on that chip for like 400 to 500 rupees. So what happens next is that this design will not be 1600 rupees. It will be, let's say, 2500 rupees. But still, that's a reasonable cost. Ultimately, my aim is to kind of get 80% performance of ICOM 705 or 7300 at, let's say, 3 to 5% of the cost. That's the ultimate goal. I am very close, hopefully. And also, I am working on a MRF 101 based 100 watts like power amplifier. If that succeeds, we'll have a direct replacement for, at least for home use case. It can compete against IC 7300 for 100 watt use cases. And that's it. Do you have any questions?
Yes. What is the sensitivity of the receiver?
The problem is the sensitivity is a problem. Currently, it uses a 25 rupees AM receiver chip, which is fine for FT8. I can receive traffic from 66 countries. The datasheet does not specify any sensitivity and levels like that. It's like from 1980s. It's a 25 rupees chip, and it will be replaced by a 500 rupees chip, which is much, much better. I can give you relative numbers. On IC 705, on a good day, I can receive 110 countries. I can hear from 110 countries. Keep it on there. Yeah. Thanks. Yeah. And on this 4732, I can hear from 86 countries on, I don't know, a good day or a bad day. The propagation changes a lot. So I'm hoping to get 80% there. And of course, I'll be doing a head-to-head comparison between 705 and the 4732 receiver, using a splitter or some kind of a thing.
What's the output power?
5 watts, and it decreases to 3.5 watts on 20 meters.
Okay.
And I am not happy with it. Hans showed this amplifier on his slides. I am not happy with it because, as you know, it burns very quickly, right? You connect it to a mismatched antenna, and the BS170 will blow. It has no current limiting, no protection at all. So I don't like it. I am working on a solution, but I have a working solution. The challenge now is to get it on the same board, 10 by 10 board, because it's not economical for Indians, at least for me, to manufacture a bigger board than 10 by 10 size. Okay. The cost dramatically increases. So the challenge now is to fit my IRF 510 PA on this PCB or a sandwich PCB on top of it and still maintain that cost, and while still getting good performance on 28 megahertz. I am not just concerned about like 40 meters, 20 meters. I want it to work on 28 megahertz, just like professional radios work. Okay. The efficiency, of course, it will have compromises, right? It won't compare in terms of efficiency, but we have to give and take somewhere, I think. Yeah. Any more questions? Yes, I have it on my PCB as well. It's a 5-watt Zener. It protects the finals, like it's a 47-volt 5-watt Zener, and it protects under like from bad SWR situations, the drain voltage, yeah, by controlling the drain voltage.
Did you develop the circuit yourself or you use sources for it?
It's the original circuit. The idea was by Bob, WB2CBA ADX, but as Hans explained, it has availability problems, right? If you use Arduino Nano, Atmega, they have availability problems, and it's a very old chip which I am not very happy with. To be honest, we should think of the new products like for the future, right? For the future generation and the current generation. So it uses a Raspberry Pico, and Raspberry Pico, the best part is the price and availability. They have an enormous supply chain, and they have promised that they will keep the market flooded with supplies. So the cost is automatically 350 rupees. So availability is not a problem for this design. IRF 510 is also not in a, like the availability is fine. So and ultimately that 100-watt PA also has a guaranteed availability till 2033. So I'm taking the BOM, the supply chain all into consideration so that we can build a sustainable radio. And it will all be open source as it is. Yeah.
What you would like to check is whether this is capable of running with a very powerful station next to it, slightly different in frequency. That's one of the biggest problems in these small transceivers. They work beautifully on their own, but when you couple it with a few other transmitters in the vicinity, which are operating, let's say, 10 kilohertz or 20 kilohertz away, you have big problems.
I think so. I think so. Sir has explained that the front end gets overloaded and that.
That's right.
And what I'll do is, that's a good idea. I'll keep my IC7300 on a full 100 watt and see what happens when I transmit on a, let's say, 1 kilohertz difference or a 500 hertz difference.
Try that. And if it does not saturate, you got a lovely product.
I think it will saturate, but let's see. I'm hopeful, but can't promise it right now.
Good.
Thank you.
Yeah, that's a good one. Next one, next. Who's UPX, OSA? Who else? Come, quickly. We are running behind schedule. You can keep it here and then. You still want me to hold?
No need. The table is good.
Farhan's predecessor not yet finished.
Good afternoon, everyone. My call sign is View2UPX, handle is Charudat, and I have a couple of projects to show. Let me start by showing from where Dhiru left. I'm showing a project called ADX, Analog Digital Transceiver. So this is the analog digital transceiver. It's a complete transceiver, monoband transceiver, can be operating on any of the ham bands with the use of plug-in coils. Okay, the output power of this transceiver is close to 4 watts. It operates in Class C amplifier, and efficiency is supposed to be very good. At the same time, it is very sensitive to bad SWR. So if you have a SWR of anywhere above 1.5, the chances are that you are blowing the finals, which are BS170 FET transistors. Okay, this is based on the Nano, Arduino Nano. So this is also based on the single chip design, single chip RX design, what Dhiru told. So it is based on the CD2003. I don't have the sensitivity figure, but I'm very happy with the response on digital modes like FT8 and receiving Whisper. This has 4 modes to offer. It has FT8, Whisper, FT4, and GS call. So it has 4 modes to offer. This is the cheapest way that a ham can today be on the air with his call sign being registered on networks like WhisperNet or whatever it is. The total cost is not more than 2,500. Okay. So this was one of the projects that I had to show. Another project is this micro SDX. This is a famous micro SDX project, which was once upon a time a very famous project. It's an SSB transceiver, again monobanders. Now many people have tried multibanders. This can easily be converted to multibanders, but I want to keep it very simple. So this is a micro SDX design, which I made the PCB for. And this again is a monobander, but it can easily be converted to multiband. And this has SSB as well as all the modes. This also gives 4 watts output, and I'm happy with the performance. This 4 watts can be given to EVQ 100 like amplifier, and it can be like, you can receive, you can output about 40 or 50 watts from that EVQ amplifier. So it's a very powerful design. And I worked with this couple of DX stations also. But for me, the DX stations from Bombay are all the Arabic states and all those things. Another design is this PDX design. The same design like the ADX, but it is using a Pico. This also has a digital mode transceiver. It operates on 4 digital modes, Whisper, FT8, GS call, and Whisper. Okay, FT4. This also gives about 4 watts of output. And this also uses the CD2003 chip, which is an AM/FM chip. Now this is an audio injector board. It's a very small audio injector board, which is based on the famous codec WM8731. This is the same codec which Farhan uses in his SBTech. So this is a very small form factor audio injector card, which has audio capabilities for a Raspberry Pi 2 with wireless. So here you see the Raspberry Pi 2W along with the audio injector card. VQ? EVQ. Okay. This is a prototype of the SBTech's project that I'm working on. Okay, this is the complete SBTech's SSB transceiver with inputs from Farhan. I have made this particular board. I have yet to test it because I'm still waiting for 2 of the PCBs. So this is the analog board for the SBTechs, and this is the digital hat which sits on the Raspberry Pi. This is a complete SBTech's project which I'm working on. I've yet to test it because I don't have an antenna right now to test, so I'll be testing it once I go back to Bombay. Yeah, that's all.
Question. You said you can connect any one of these devices to a 100-watt amplifier.
Not a 100 watt. I said EVQ, 50 watt amplifier.
50 watts, fine. Have you done that?
No, I have not done that, but some people have done it.
The reason why I'm asking is there is so much output feedback from the 100-watt amplifier which might saturate this because these are all empty boards.
I agree. I totally agree.
So are you looking at putting these inside?
These are all digital boards. So
okay. That's okay. As far as RF is concerned, 100 watts will work its way right back.
I don't have any 100 watt set which is close by to be testing. I will rely on Dhiru's thing for whatever he says, whatever he observes with the interference. So I will go with that.
No, it's not just interference. What the amplifier will do is feedback into your input and the whole thing will oscillate. And it will become totally uncontrolled.
I have not tried it, sir. I have not tried it personally because I don't have it.
Anyway, look out for that when you do connect it on.
Yeah.
Thank you.
That's it. Any questions?
Yeah. Next. Please. forget your call. KD. Okay. VU2 KD.
Not yet. Oh, yes, he did. Yes.
Good afternoon, all gentlemen. My handle is Shofi and call sign is VU2 Kilo Delta. And I am from Delhi. Today, lot of homebrew is there, but basically my design is concerned on the Farhan, which is come to this field. That is BTEX version 3. And after that, there is no AGC circuits. This is the BTEX version 3 they simply designed. And there is a lack of AGC. So simply I added this AGC circuit on this field for good quality of receiver production. Another is the NR60. Few people are also familiar on this NR60 radio. That is built in the 1960. Those days there is no, few people are not aware of this IC. But those days that is especially detailed on the BC549C transistor. With the help of this simple design transistor, I work a lot of station, not only in a DX station also there. And with the help of 10 watt with the simple dipole antenna, and I work on this NR60 near about 10 years. And another is it is the micro extender which is already explained by the Charu. It is side by side. This is also I have done. And question is that the power amplifier is there. And another question is the feedback also there. And especially I tested this micro SDX with my linear, and I am getting the 70 whiskey power. There is some issue with the feedback, and that is isolated. But at this moment, I can present here. The next time I will present here with the help of oscilloscope as well as a spectrum analyzer. That much I have done. And another, so many projects is going on. I don't want to discuss. Anyway, thank you.
Yeah, VU2, VU3 OSA. It's his debut, huh? Good.
Good morning all. I'm VU3 Oscar Sierra Alpha, Gaurav Sharma from Mumbai. I have two of my projects, homebrewed, which I have to display. Firstly, I have this micro SDX, which is made in the form of the size of a credit card. It is that same USDX which all of us we are made. It is in the size of a credit card, reduced. It's a design by VU2 UPX Charuji. The output is again around 3 to 4 watts using the LPF, and it's a mono bander. All the components used are SMD. It's 0805. All of them are SMD, and I had a lot of difficulty in locating them across. So this is the one. And what I've done is I've made a box. It's a cookie box from Indigo Airlines. I modified it as a case. So I have this PTT. It is again it's a PTT with speaker. So I use it. And recently I was in Delhi. So they have a net conducted on 7060. And I was able to have a QSO in Delhi. Locally, I was using dipole antenna, a 40-meter dipole. So I was able to like have a QSO with this. So this is the box which I've got it made, a customized box. SOTA. Yeah. All the components used are SOTA. हाँ SOTA rig. It's as same as SOTA. ठीक है मुझे इतना नहीं. The other project which I wanted to display is the ADX, which already UPXer has already shown. Now it is again a monobander, but it has FT8, FT4, JS8 and JS4, and I've assembled it in a 20 rupees junk set-top box. Like, if you see this is the way I've assembled it with the LEDs out, and you have the USB out here. Here you have to only input 12 volts and the antenna, respective antenna for operating this. So you have to only change the LPF, and it operates with the CD2003 IC, and you can replace the respective LPF for the band whichever you want to operate. So that's it from my side.
No questions.
Thank you so much. Thank you very much.
Do we have any more? Oh, we have to PTR. Okay.
Next homebrew challenge will be done by PTR. So Tyagarajan. So he'll be exhibiting his product. Over to you, PTR.
Sir, 1 second, sir. Announcement. Lunch is ready. So those of you who want to go for an early lunch can go to the lunch area. Thank you.
Power. In the side now.
Where is KD?
Soldering techniques where soldering technique will have it. They still have not. But others hall they won't be in sessions. What is happening is most of the crowd is there. So we thought that the one session will have it there. So I will announce.
Every streaming session is there. We have to use like that techniques. At the same time, we will call them also. Okay.
Who is having?
Problem
Hello.
The next session.
Yeah.
I talked to you yesterday, so why do I have to ask this?
I tried to cover it as much as possible.
That has gone into a different screen. Just see.
विंडोज कैसे चेंज हो गई?
Hello. Good afternoon, fellow hams, ladies and SWLs. I am Tyagarajan, VU2 PTR from Chennai. Handle is Tyagu. Today I am going to present about electronic load. I think I wanted the circuit to be projected. There is some technical issue going on. I hope they will sort it out. I wanted to share the circuit also with everybody. All of you would have heard about dummy load. Dummy load, we use different wattages for checking the output of the transmitter. So we can homebrew a dummy load, and also commercial dummy loads are available. But when we construct a power supply, a linear supply, so we need to check the performance of the power supply. One, we can just check the voltage. What is the output voltage? That we can measure using a multimeter. But if it is supposed to deliver 13.8 volts, and if it is rated for some 20 amps or 30 amps, when we draw that much of current, the output voltage should not fall. So that is the main criteria. Similarly, when we homebrew a power supply, we have to set so many things: over voltage trip, and also the current limit, all that. So for that, we have to load the power supply, what we have constructed, or even if we are buying a new one, we have to test it. Commercially, a lot of electronic loads are available. Many of the manufacturers, they are using a resistance bank and other arrangements. But for hams, we don't require that much of high current. So maximum, the commercial rigs, they take about maximum 20 amps. So if we have a electronic load to test up to 20 amps, 30 amps, that is more than sufficient. So here, what the principle is, see, many are, when they are testing, they are using the automobile bulbs. They just connect the automobile bulbs which are rated for 12 volts. It draws current and they can see. Some people use the nichrome wire and they connect it as a load, and the nichrome wire becomes red hot. Or some are using diesel engine heaters. But in these cases, we are having a lot of disadvantages. If you are using bulbs, number of bulbs, the brilliance is so much, so it will be detrimental to the eyes. And also similarly, if you use nichrome wire, it will become red hot, so somebody can get burnt. And similarly, the diesel engine heaters, it will also become red hot. So there is a little amount of hazardous and safety issues are there. And another important thing is, as hams, we don't want to use step changes. So when we collect one bulb, it may be drawing about 4 amps. When we collect another bulb, it may be about 8 amperes. So it cannot be a continuous variation or increasing the load. And also we may like to know what is the output voltage, how much it is dropping at the rate of the particular current. So that is an issue. So here I have designed and homebrewed an electronic load. Here the principle is I am using MOSFETs. MOSFETs, we know that when we give bias to the gate, it draws current. Yes. I'll come to that. Thank you. So this is the circuit. I was worried whether the projection will there be any problem. Now in this actually you can see power supply system and also the various MOSFETs and also an operational amplifier. So in my gadget I have used 4 MOSFETs because I wanted only up to 20 amperes. Because 20 amperes if it is designed for a short duration we can even go to little higher current. So I have used 4 MOSFETs, and the MOSFETs, the gate voltage is given through a potential arrangement. So there is a small power supply unit which converts the AC voltage into 12 volts. From 12 volts, it is again converted into 5 volts. So the 5 volts goes as the bias voltage. And we can see in the circuit, there is a fixed resistor and also a variable resistor 1K. The variable resistor is this control, okay? And what I have done is the MOSFETs are mounted on a huge heat sink because it will be dissipating a lot of heat. So when we especially go at higher ampere, it will dissipate a lot of heat. And also, I have provided a high-speed fan. So temporarily, to open the cover, I have disconnected. There is a high-speed fan. This high-speed fan will be blowing air and cooling the heat sink continuously. These MOSFETs are powered by the LM324. It's actually a quad operational amplifier. It has got 4 sections. It's a 14-pin IC, and conveniently it is covering my need of powering, giving the gate voltage to the 4 MOSFETs. If somebody wants higher ampere, they can change the IR of P150 to P250, or we can add one more IC, that operational amplifier, and we can have another 4. But the heat sink area has to be large to dissipate the heat. So that's the idea. So here it is very, very simple. So as we increase the voltage, it goes to the non-inverting input of the operational amplifier. Immediately it is increasing the voltage to the gate. So all the 4 MOSFETs are fed from the same source. So all the 4 MOSFETs, the current will increase and it will share the total load. So when the current is increasing, there is a small resistor in the source. That is a 0.1 ohm. So the drop across that also increases. So there is a resistor through which the feedback is given. So actually here it is actually a voltage to current sink arrangement. So it gives the feedback and the voltage is maintained and the current is maintained. So it is very, very simple. Here there is no hazard of anything. Everything is in a cabinet and very safe, and one can test very, very easily. I want to just rush up because there are so many other speakers. So I will just briefly tell what is the methodology to test a power supply. Unfortunately, I don't have a power supply, otherwise I can demo. Here there are 2 terminals for positive, negative, and also there is a safety fuse, and this control is for increasing the current. That's all. So we have to connect the positive and negative of the power unit to be tested to this directly. And then we have to start slowly increasing. So I have employed a voltmeter and a current meter. Voltmeter is a digital one, and the moment we connect the power supply, it will display the voltage from the power of the unit. And here I used a Hall sensor for measuring the current. What is the circulating current? So as we start increasing the bias, slowly the MOSFETs will start increasing and the current will be shown. So this test, when we are especially going at a higher voltage, higher current, we have to do it very fast. So slowly increase, observe the readings, take the readings, note down, and then reduce it. So that's all. So any questions? No, here there is no need for crowbar. This is only a load. It is like a resistive load, but an electronic load. Crowbar comes only in the protection system of the power supply unit. Pardon? Yes, yes. Digital ammeter and Hall sensor is used. Hall sensor converts the circulating current because directly we cannot measure the high current. So from the Hall sensor output, it is connected to the digital meter. Any other questions, please? This is the whole arrangement. So there is a small SFPS which gives the 12 volts. Yeah, this is the Hall sensor. Unfortunately, I don't have any pictures, otherwise I could have shown it. And this is the huge heat sink. All the MOSFETs are mounted on here. And the operational amplifier is here. This is totally wired. So very, very compact.
I'll cut down.
Any questions?
Then we can go, otherwise we'll go for lunch and then come back. No, we'll finish and go.
Okay, thank you.
There's one more.
He's not come, and the kid also is not come.
Yeah, the kid
These two are the same, so everything is over.
Thank you.
Then, no.
Yeah, I've gone through a bunch of very interesting projects. One thing, I've seen a lot of receivers, transceivers, and things like that, but what you need to do is specifically look at something like QST. When QST, the ARRL magazine, tests a transceiver, there's a bunch of specifications which they test against. I think it'll be a good idea for you folks, whoever have been making these transceivers, to look at those specifications and see whether your device meets that. One of the biggest problems, I've been working on this for more than 30 years and I have a little experience in making receivers and transceivers. The biggest problem I had was the dynamic range is not sufficient. It's very susceptible to interference. And the moment you add an amplifier onto it, all hell breaks loose. All you get is one massive CW output, whether you're speaking into it or not. So things like that you got to be considerate of. So the thing has, you got to look at things like shielding the entire enclosure, how you prevent RF from getting inside. Right now I'm working on battery BMS systems, and I know it's a bear to make sure that there is no interference inside. So those things you need to consider. But QST, any of the QST magazines which describe new rigs would be a good place to start. I've been impressed with the amount of work which has been done into this whole project, into all the different projects which you have exhibited today. Especially some of the people who came up with mechanical designs. That is quite impressive. The one with the satellite antenna rotator, that's one of my pet projects. I was really impressed by the amount of hardware which has gotten into it. But the prize today will go to VU2 UPX for just the sheer amount of work which you have put in making so many multiple projects. Congratulations.
This Fox and prize when it is going.
Thank you.
Fox and prize.
Thank you.
Afterwards.
Let's give him a big round of applause. The judge for LARC has won the contest himself. Please.
Really?
Yeah, we have the next session. It's going to be a quick session before we break for lunch. Lunch is already started, so but we will have this session. This is a short session. TBR, are you ready? Yeah, please. Everyone is hungry.
Okay, good afternoon, everybody. This is VU3 Tango Bravo Romeo from Chennai. My name is Bala Subramanian, handle Bala. I have been doing since the last 3 years on various digital modes. I spent a lot of time, on finding what are the things are available, because in the world map, digital flag was never there. So it was a shame we sent a rocket to the moon that we don't have a single digital ham activation, only one in Delhi as a repeater. So then the dependency of repeater I realized was not required with the hotspot. I showed you the hotspot. So those sort of hotspot can work out a really nice one. So in this picture you will see I done my part 1 last year. This time I am going to show you it different. Earlier participant also showed you about Ecolink, etc., etc. I'm going to find in this last 1.5 to 2 years what I have seen and tested out, and it is working fantastic. Okay, so this is just a image. Next slide, please. So next one. So okay, the first one is next one. This is a transceiver, digital transceiver. There are 3 or 4 items I am going to discuss, because at the present juncture, the market rate for obtaining a hotspot is very expensive, anything $200 to $250. Then it is parts are not available, etc. In fact, some radio which are manufactured 2-3 years back that are still cheaper. You can obtain like a Bofang 1801 for almost like 7,000 to 10,000 rupees. And also Radio DT GD77 is also. I'm going to today talk about this using this type of radio. So this is called a Open GD77. It's an open source software. Open GD77 helps you to make your handy, that is a GD77 and a 1801 of Bofang into a hotspot. So for less than 7,000 to 10,000 rupees, you make your hotspot for making a DMR, NXDN, all those Fusion, M17, etc. So you need to connect your radio with your computer or Android phone. On the Android phone and PC, you will run a software called Blue DV. This Blue DV software will talk to another radio through the hotspot. If you have another DMR radio, you can talk, or you can buy a 2, Bofang. One way you make it as a hotspot, another for talking. Okay, so you can do that. So for 20,000, your hotspot you are spending for 1 unit. Now with the 2 radio, you can get one, make it as a hotspot, one for the talking. So this is a very good project. You can see on the right-hand side, who are all the last heard call sign, who made a call, and the present call sign. This is Kevin from New Zealand. So C for FM, that is the protocol he is talking to. Okay, so this is a very beautiful system. I want you to try, next slide please. So I want you to try this one. So I'm just going to tell you what is this hotspot. We spoke about a hotspot, etc. Now, the hotspot is nothing but a miniature repeater. Okay. So, a repeater, like you talk to with a line of sight or on the hilltop, you keep it 30, 40 kilometer, you try to talk. So, that is the same repeater is catching and conveying to another. The same way, our hotspot sitting at home, through your handy, you can talk to the hotspot. That hotspot will connect to the internet and throw the outgoing as a packets. Similarly, all the incoming is comes to the hotspot that converts into analog signal and transfer it to the handy. Okay, so this is the function. So there are various functions given. We can do the bridging, like hotspot itself, it runs a software called PyStar. it has no capability of doing a bridging. It has only a purely a repeater function, nothing more than that. Okay. So I have done in Raspberry Pi, I'm running a 4 server where I'm bridging the DMR to D-star, D-star to DMR, and connecting to NXDN gateway, M17, Ecolink, All-Star node, etc. So I have done that. I'm the only person in India which I have done this reflector. No other people have tried. I don't know, maybe it costs money, time, and also maintenance. You have to keep 24/7. For the last 2 years, I have been running 24/7. Okay, only in case of some very bad weather, now Chennai is experiencing. It had I don't know, every time I come for AmFest, that is a weather problem. So I give a rest to my server also. You take rest also for 2-3 days. Okay, next one. So this program, that is HTDV means digital voice, and ST1 and ST2, you can do a direct, then you can talk to the HT1 to HT2 voice module. There is a module 1, B, C, and D. These ABCDs are described equivalent to frequency. Okay, you set to C, you say, in the software, that is set to a particular frequency. You don't have to key in or anything. Just select a C, it will automatically set in. Next one. Yeah, next one. Okay, next one also. Yeah, okay. So, because of the time I'm cutting out on the repeater function, most of you know. This is the second item I would ask you to look into. First, I told you about OpenGD77. Now, this is a very good board actually. It's a replacement to Raspberry Pi. You don't need a Raspberry Pi. You go and get in the market, it's about $30, but this is freely available. See, this is called MMDM HSCSB hat. So this will, on top, if you want a radio, you have to have a MMDVM RF board so that you can communicate. Without a Raspberry Pi, only with this board. So then again connect very similar to the computer, then use this BlueDV software. Okay, so BlueDV software you can use also with a dongle. There is a dongle available throughout the world. It's called a DV Mega Switch 3000 or Thumb DV. There are two models are available. You can plug into your PC, and BlueDV also you can use. You don't need all this hardware also. You can do that. That I explained in the part 1 of my last year. Okay, so next one please. So this is a beautiful IX DV switch. It's a free software. This is one of the very good software. Supports many protocol. Okay, you can use for M17 protocol. You can use for All-Star Link. You can use for D-Star and DMR. And from a DV switch, USRP client. This is a USRP client and IX client. It can use both. Okay, so this is a very, very good software. It is a free. It runs on the Android phone. You can very well download it. If you have a problem of setting up, I'll help you out to do that. Next slide, please. So we have been talking about BlueDV, how it has been helping other hardware to get connected and do it. This is a very versatile software. This is written by PA7LIM David. He has written Peanut software. We use Peanut software. It's a free software. From the Peanut, I can connect to 8 other rooms. I'm doing a bridging, and the sound clarity is very good. It's first of all, Peanut is free. BlueDV is also free. You can use with this one, the dongle I told you. So the dongle, you can very well put it on the computer, and you can use the 2 other mode I told you about this. Okay, so you can try this one, both of them. So, yeah, the BlueDV, there is a dongle. I can show you that. sorry, I can't, it will take time. It's a small USB type of a link. So it has got a transcoder built in. So the transcoder, it's a AMBI 3000 we call it, developed by DVSI company in USA. We pay royalty, that is why the price is very high. It costs something like 120 euro. Okay, so this is a very small unit. Okay, so you can use that also. And of course, you show me the slide here. Next one. No, you just go slide next one. Yeah, okay. So after this Blue DB, there is also for a Mac user. We have been talking about Android phone and also about the PC. What about the Mac user? So there is a software called Buster, B-U-S-T-E-R. So this same dongle, you can connect it to your MacBook. Then you can use all the protocol, okay, all the 5-6 main protocol. So it gives you, it is not a very fancy software, but it does the work. With whom you are talking, what is the connectivity, etc., and his call sign and his name. This is what the basic details we require. So those details are totally available. So one can view that it's a software is called Buster. Okay, so next one. Next one. उसके लिए टाइम नहीं है ना ओके नेक्स्ट वन जूम okay, sorry, we have some connectivity issue. There is a single board, single board. It is not a Raspberry, but developed by one of the ham. It has got a built-in, the function of the Raspberry Pi, then also the dongle I mentioned to you, and a couple of other things. So you can run Peanut with that. You can run a BlueDV software. You can make that as a hotspot, that board, and you can do repeater, function also in that. So that is also, it is costing something like 120 euro. I would suggest you buy that Zoom Spot. Okay, it is called a Zoom Spot. So you can buy that one. So that is very, very helpful to, okay, next one. Okay, so another good news for the Android user, because a lot of people have a fancy to hold a radio in their hand, okay. They think by holding this brick in your hand, I call it brick sometime, it's very heavy, and they think I'm the ham. If you hold, because you are one among the thousands or few lakhs, they think only police people can keep and other ham can keep, no other people. But if you have the more functionality given by Android phone, my Android phone cost me 65,000 rupees, very fast, everything, it's more than a PC, powerful PC, So there are software developed by certain people to do all the digital mode using a software on an Android phone, so that, see, very simple, I have say another thing is, when you want to do QSO, you are in a RF mode, you have to go to shack, right? But with the Android phone, you carry shack in your pocket. Okay, then while you are sleeping, we are all aged people. Every time you can't be attentive like this. So you need to relax. So on a bed or on a couch, you are relaxing. You are talking to the people with your headphone, Bluetooth. This can be done. So this is a software called Droid Star, D-R-O-I-D-S-T-A-R, Droid Star. This is one of the free software. I don't know why he made it free for the people, but he has some meaning to do that. So it helps all the people to talk to M17 room, DMR, D-Star, Fusion, All-Star Link, then Ecolink, all these things. So it has got interconnectivity, all the thing. It is, after all, a free software, okay? So for a same software, by name of Dude Shield, okay, Dude Shield is available for PC also. So you can download this software, Dude Shield, for the this PC, and you can do the same functionality what I told you. So it's a very beautiful software, both of them. नीचे आ जाओ पर ने Okay, I finish it. Sorry, I have a problem with this connectivity. This all happens in the ham's life. If everything goes smooth, there is no ham expertise is born, you know. So every time you resolve, you feel happy about it. So after this, this software, there is a lot of people have been wanting to do away with, you know, anything, like even phone they don't want. But they want to do some sort of a QoS. So how do you do? There is a way to do that. So you run a software called DV Switch, which runs on a Raspberry Pi on a Linux machine. You put it in a shack. If you have a static IP, it will help you any part of the globe you are. Just go to your browser and type the IP address of that static IP. Your client will come on top that. Okay, on the client you can do, you are given a password, your call sign, you put your password, so nobody else can use your system. Okay, absolutely is security, absolutely protection is there. And another important, you have a 10-15 friends or a club, you can also give access to your server. Okay, that is another beauty of it. You have a small club of 20 people, so you can use a DV switch and give the connectivity by giving access to them. He can also put a IP address, but while logging, he'll put his call sign and his password. That way, individually he'll be talking, the other guy will individually be talking. So all communication is open. So this is a DV switch is a very, very simple, actually, very simple software. And you can run on a Raspberry Pi, which costs about 5,000-6,000, Raspberry Pi 2 or 3. You don't have to go for expensive 7,000, 8,000. Okay, so this is a beautiful system you have. So the system for DMR, lot of good phones are there. You can have a Anytone and you know, Motorola phone also coming with a DMR. Then Radio DT. So many brands are there. For a D-Star, you have very limited, so ICOM and Kenwood is there. So for a NXTN and for M17, you have to buy another. So you need a 4 or 5 protocol, 5 radio to talk to via. So that is the reason I showed you I am making that analog to digital, you know, the unit, which is going to be very, very helpful to many people. You have one radio to buy with, you know, and connect to this system, my system. So this is what I am planning to do. Okay, I am sorry, the organizer have told me to finish it as quick as possible. We have wasted lost our time in other things. So if you have a quick question, please ask me. I'll try to give you a reply. Then we can proceed for lunch or something. Any question, please, auditorium? Anybody about digital mode? You want to ask any question? VPR, you have any question? Okay, so I'll hand over the mic. You can go to qrc.com. You can find my telephone number and call sign. Please write to me if you have any doubt. I'll help you out. Thank you. Take care. 73. Bye-bye.
Let's give a big round of applause to TBR. Sir. TBR. Sir. Let's give another round of applause. Thank you so much. Okay. Now I call OZ on stage to declare the winner of the fox hunt.
Okay, the winner of the fox hunt is VU2 Zulu Mike Kilo.
Let's give a big round of applause.
Here you go, sir. Congratulations.
Give me a smile.